In this segment, we're going to come back to named entity recognition as a task. We're going to talk about how the kinds of CRFs we've built up so far can be useful for it and what state-of-the-art systems look like. So first, we have to talk about how NER is evaluated. So we've never really had this question before. We've always just been thinking about straight-up accuracy, even for tasks like part-of-speech tagging. But NER is a little bit silly because if you just predict O everywhere, you get 66% accuracy on this example. And in general, depending on the data, you might get even higher, like 70 or 80% overall. So somehow accuracy doesn't actually reflect what we care about. What we care about is how many named entity chunk predictions did we get right? Like basically, did we find the named entities here? And so this requires us to look at two notions of performance. So the first is precision. Of the ones that we predicted, how many of those are correct? And then recall is, of the ones that were truly there, how many of them did we find? And so these are kind of metrics that are useful for sort of detection problems. Like imagine if there's just sort of a whole bunch of data about events, and we occasionally sound the alarm that we detected an earthquake or something like that. These are metrics that can kind of be used in this sense where we could think about it as like an imbalanced classification setting where like one kind of tag or option is sort of the default, and then we care about predictions deviating from that default. And then the final piece that these get combined into is what's called F measure, which is taking the harmonic mean of these. Okay, so just to make it explicit, if our system predicted, let's say, this person chunk correctly and this organization chunk, but then it just kind of went right over Hangzhou and didn't predict it, this would give a precision of 2/3 because we've predicted 2 out of 3, the precision here is actually 1 because we made 2 predictions and they are both correct. The recall here, that's what's 2/3 because there were 3 chunks that we should have been finding and we only found 2 of them. And then the F measure is the harmonic mean of those, which is going to be a little closer to the recall than the precision in this case. If instead we predicted a 3rd chunk that was incorrect, then we would have precision of 2/3 and recall of 2/3 both. All right. So the CRF with lexical features we've built up can get around 85 F1 on the Connell 2003 data set. So this is a 4-class NER task built on Newswire data. So you have to throw in some somewhat fancy features in order to get this, but this is pretty good performance. And it's not easy. It's not easy to get here with kind of naive classifiers or HMMs or anything like that. So it's worth asking, what else do we need to capture about this task? And one of the big factors in NER is world knowledge. For example, the delegation met the president at the airport. Tanyag said, you probably don't know what Tanyag is. If it's a person, in this case, it turns out it's an organization. It's a Serbian state news agency. But by looking on Wikipedia, we could say, oh, okay, like this thing looks like an organization. Great. That's one big factor. Another way to handle this is to use non-local information. So, for example, earlier in this same document, we might have said the news agency Tanyag reported on the outcome of the meeting, and that occurrence is going to be an organization. Hopefully the model is able to pick up on that when we call it a news agency. And then the fact that we have the same term showing up in 2 places, there's an idea that we should have typically 1 sense of each word per discourse. And so we're not going to talk about Tanyag agency and Tanyag person. It's all just one thing. And so there's actually some very nice work due to Jenny Finkel et al. From Stanford and Ratanov and Roth from Illinois on using kind of more complex like factor graph structures in order to capture this, or kind of sequentially decoding a document. All right, so from the Ratanov and Roth work, basically they built a system that used a bunch of these ideas. So they had using Wikipedia as an external resource, non-local features, and a model of so-called word classes, and they were able to get around 91 F1. So a pretty big upgrade from that standard CRF that we've built so far. So this actually was the state of the art for a long time. The LSTM-based methods in 2016 were able to roughly match it. And this is one of those neural CRF methods that I mentioned, where you actually compute the potentials phi with an LSTM. And so then the CRF layer looks the same, and there's ways of kind of integrating the CRF inference with backpropagation. So that approach was able to get roughly the same performance, but nothing really went beyond that until pre-training methods. So Elmo got around 92, and then BERT got a bit higher, around 92.8. So the takeaway here is that this external knowledge is a huge factor, and so the LSTM CRFs were able to do pretty well because of word embeddings like skipgram, and then Elmo and BERT were able to kind of leverage stuff even more heavily here. All right, so people aren't really working on this kind of NER task so much anymore. The main focus now is scaling up. So this is a figure taken from Unsel Choi's work, where she and her co-authors looked at creating a type set with 10,000 types in it. So there's been a trend over the last decade to go from this like 4-class task to 17 classes to 112 classes, now to 10,000 classes. And so obviously accuracies are much lower. There's a lot of challenges associated with predicting in such a large tag set. You no longer have mutually exclusive tags. They now overlap. So you'll have tags like person and also president, where you want to assign both tags to the same person. And so these large tag sets can be very useful. They provide much more fine-grained information that can be used for downstream tasks, but the kind of applications and uses of these are still being explored. So that kind of tells us how the CRFs that we've built so far fit into the overall picture of where NER is these days, and gives you an idea of the state of the art on this task. That's the end of this segment.